get the recording on. Good morning, everyone. This is
joined for online.
Collin College. Hello. Today is November 2nd, and it is 10 o'clock or 10:04 at Preston Ridge campus at Collin College, I said. This is the regularly scheduled meeting of ITSC 2309. And begin here. Let's see, we've been working in module. What module are we in? I need to go ahead and make that assignment. Over and look at the modules. Okay, we are working in module 8, and I don't think I've not made the assignment for chapters. I've not put a due date, or have I put a due date on number 7? I have not put a due date, did I? Let's see what I've done with that. I need to go to edit. Good morning, Sal. How you doing? Let's see. It looks to me like, have I put the due date yet? Yes, I put the due date on it as October 19th. So module 7 is due. I want to talk a little bit about module 7. And module 7 says, essentially, select account number, count. This is the answer, by the way, to module 7, exercise 5. So find duplicate account descriptions. So if I execute this, we'll get the account description from GL accounts grouped by account description having count greater than 1. I believe I put one in there that did. No, I didn't put it in there. If I had one, and if you want to test this to see if it's working, go over to your Object Explorer, open APDB, open the tables, and go to the GL accounts, right click and say edit the top 200 rows. And pick any one that you want. You can say again. Oh, I'm sorry. Here I sit again without turning on the overhead. My people are coming. I didn't have anybody here a minute ago when I started, so nobody said, hey, your overhead isn't on. Okay, we'll let the overhead come up. You can zoom in. Some people prefer to watch it on their screen. You can, if you zoom, you can watch it on your screen. If not, the overheads are warming up right now. For the recording, it'll be there in a minute. I went into the GL accounts, and I'm going to choose one of them, and I'm going to change that to cache. I don't worry much about changing data. It will change what you get from your queries, but that's okay. If you want to put it back, all you have to do is run the AP, create AP SQL, and it'll put it back. It'll also bring all your dates forward. And so now I have 632 and 100 are both cache. So if I run this code now, I should see that I have 2 account descriptions that are cache. Okay, so that's testing it. Now, somebody wants the account number. Select account number, account description as count. And because I am a good programmer, I know, I've studied my SQL, I know that if I have anything in that select line, and I have an aggregate function, then everything else has to be in the group by. So I put this in the group by. All right. And now I'm really amazed when I run this and I get nothing. And so the question is, why am I getting nothing? I'm going to mute. Why am I getting nothing? Well, if you think about it, account number is the primary key to that table. So if I group by the primary key, how many things am I going to have in each group? Only one. It's unique. So it's not possible to have count greater than one. I will never get anything. The count descriptions are the same. Okay, to fix that, I go to my subselect, which is the topic that we're currently discussing. And I can select account number and description from GL accounts where the account description is in. And here I have my aggregate function, select account descriptions from GL accounts, group by account description having count greater than 1. Okay. Now, the thing I like about a subselect is that's not correlated. I can just run the subselect by itself most of the time and take a look. Look, I'm getting one. So now I'm going to test it by running the whole thing and see if I get the account number. When I execute this, I get two of them. Account number 100 and account number 632 have duplicate descriptions. And get that down. Okay, in order to do that, in order to get it grouped, I had to bury the aggregate down in a subselect. It's very handy for that. A subselect hides stuff. So if I say where the account description is in or greater than or less than all, something like that, I can have a subselect down here that groups by something where I get to hide this from the account number. Now I'm going to have a little bit of a problem if I try to return the count, but you'll see the count, and there you'll see how many of them you've got. Notice we saw both lines, so we assume we had 2. Okay, let's see. Any questions? Okay, I've turned your microphones back on. If there's any questions, you may ask them now. You don't have to if you're online. Okay, I'm going to mute the microphones again. Okay, anyway, subselects are very handy things. Let's see. We can also do this with a derived table, which amounts to the same thing. This is just an example of doing the same thing. I'm hiding the select and the grouping in a subselect. Now notice this account number. So what I'm doing is I'm creating this account and I'm joining it. So my outer table is the GL accounts. I'm joining it to the query. If I join it to a query, I can do that because this query is a table. Every line everything in the select statement has to have a name. You can use the name, but if I select a count or a sum or something like that in the account description, then I have to give it a name. I can't have anything that returns no column name. I also have to name the query. Doesn't matter a whole lot, except since I'm naming the query, because I have to join the GL accounts, I did not have to rename GL accounts. I just do so to avoid typing. I did have to name this query, particularly since I'm trying to join that query as a table. So the important thing here is that a query is a table. It has all of the rights and privileges of any other table in a select statement. Of course, I can't insert into a query yet. We're going to find some later that we can, but right now we can't. Okay, so these two are the same. The one that beginning here I have on line 19 and the one that I have beginning on line 31 are the same query. They will both have the same execution plan. If you want to learn about execution plans, take my advanced programming class. But they're both going to do the same thing. When the query optimizer gets hold of it, it's free to change one into the other or do it any way it wants to. And it's usually pretty good about making the decisions. The only time that I would mess it up is if I wanted to count the, let's see, what is it? Account number. So if I said count account number in there, that would slow down the query a little bit because it would have to go into each record. If I just say count star, that runs a little bit faster. But since I'm saying that in both of them, these two should have the same plan of execution because they both do the same thing. Here we have that SQL is really an artificial intelligence language. I specify what I want and the computer programs itself to get it for me to a certain extent. Some things it can't. Okay. Oh, here we go. Okay. I'm going to look ahead just a little bit, and I'm going to talk about my first topic in the next class. Since we're getting pretty close to the end of the semester, we're in November, and I think of the semester ending the last of November, but I think we have one class meeting after that. I believe our finals week starts on the 10th. By the way, on the last class day will be the deadline for turning anything in because I have to get everything cleared up. And unless I put a due date after that. So when we get into finals, anything that is past due turns into a pumpkin. I can put a due date after December 10th, but I have to get everything cleaned up. So that's kind of make sure everything's in by then. That's kind of drop dead. But if the due date goes past December 10th, everything's fine. Let's see. Okay. My first topic in the next class, which is kind of where I'm just pointing us now, is the programming language that comes with this. Now, all databases have I wish I had a drawing tablet here. I think I'm going to buy me one. I can switch over there and draw pictures, but I would draw something, a Venn diagram, and I would draw a circle and I would say, this is SQL. And then I would draw a bigger circle around that where it looked kind of like a fried egg. Excuse me. And I would say, this is, outside of that, I'd say, this is TSQL. So that language, this is the language, the programming language that is wrapped around SQL. SQL, in theory, is supposed to be universal. It's supposed to be exactly the same for every database platform. In reality, this isn't true. But in theory, we think of it. So everything that we are doing in this class, you should be able to pick up and drop right into Oracle or MySQL, and it should run just fine. Now, things like Go are unique to SQL Server, and we talk a lot more about that later in the next class. But this class, it really doesn't matter what platform I'm using. I could use Oracle or any of them. They're all the same. Some things will be different. The way you do if object ID such and such is not null, drop table such and such, that will change. but because that's the TSQL, T-SQL, also known as transaction SQL or transact SQL, whatever. We usually just call it T-SQL. T comes off my T-SQL is easier than TSQL. Whether you say SQL or SQL, they are not always the same thing, but for the most part, for this class, they are. Okay. This is a TSQL program. Now, this is not SQL. I'm stepping outside of SQL. So when I say go, that starts a program. When I say go again, that ends the program, starts a new program. This might be comprised of a bunch of SQL statements. It's fine. Okay. Let's get into it now. This is the TSQL programming language. So I'm going to start here on line 48. I declare a variable. My variable's name is ACCDESC, which is supposed to kind of mean account description. So I'm basically going to do the one above in TSQL. TSQL is generally not as efficient as SQL. So doing it this way might be simpler for your logic and programming, but it will be better to stay in SQL as anytime you can. And since I can, I would not go this route. Okay. Declare. All variables in this language begin with that @ sign. I believe it is called an et sign. From the Latin of against. So it's also was the sign for currency, I believe. I could be wrong on that. We call it the @ sign. So @ ACCDESC, all of the variables in this language have to begin with that. Other than that, the same rules apply to these variables as apply to any other variable. You can't have spaces in the middle of it. You can't put those in square brackets either and get it that way. I advise never to use spaces inside of any identifier, ever, when you're programming. It is just, it's bad news. When you're setting up your computer, avoid having spaces in the folder names, unless it's a folder right at the end of the list and you're just keeping your Word documents in there, that'll be fine. But if you're programming in your programming environment, you don't want any spaces anywhere in that chain coming down there. That will give your program the hiccups. So I've declared a variable, and now a variable comes into existence. What type is this variable? We're going to talk about types further today. This is varchar 50. Well, where did I get varchar 50? I went over and looked at the table, and I said, what is the account description in the table GL accounts? And it turns out this guy is varchar 50, so I made him varchar 50. Some platforms will allow you to say, give me a variable and make it be the same type as that one in the database, so I don't have to look it up and type it in there. SQL Server is not that sophisticated. Not that I'm knocking SQL Server, it's just that it is not a real high-dollar database, which is fine. I don't have a high-dollar car. This is the assignment. I select, I'm saying account description gets account description from GL accounts grouped by account description having count greater than 0. Now, I'm going to crash here, right here, if I return more than one account description from that query. So I'm making the assumption here that I'm going to have to do something else, and I'm not going to talk about something else right now. So I would have to process through a group of statements, a group of values. But if I only get one value back, this will work. So I'm really kind of hanging out there on a thread, because if I get more than one back, I've got problems. Now, I've put the value that I got, I believe it's CASH, into the account description, and it's going to stay there until I either change it or I hit a go at the end. In that case, it goes away. Now, from here, I have the account description, so I say select everything from GL accounts where the account description is equal to what I got up here. So I'm just putting something in a variable and then using that variable later in another SQL statement. Go ends the program, and the variable named at ACCDESC goes away. And I think that if I run this, so I'll run the whole program, execute, and notice that I got the same two values. I got value 100 cash and whatever the other one is, 632 cash. I have a was that someone logging? I heard a bleed. Is that someone logging in or someone wishing to communicate with me by text? Let me check my texts really quickly. I have a group of people. I have workers remodeling. Okay, I'll deal with that later. Okay, so this is really in the next class. And I don't want to burden you with a whole bunch of nonsense here, but I do have the ability in every database platform to declare a variable, to put something in that variable, and to use that variable or change that variable later to do calculations with it. And I pretty much have to have that, but it's not SQL. SQL does not have variables. SQL does not have an if statement. However, I can do an if statement with this. So I have lots of if stuff. I can say if the count that of the things I'm going to return is greater than 1, then don't do anything because I'm going to blow up. Well, I'm going to have an error, not the end of the world. Okay, now I forgot to turn on the recorder last time, so I'm going to cover again, as we probably have to do, the correlated subquery. Now, the correlated subquery we talked about last time, but I forgot to turn on the recorder and make sure I'm on now. Okay, I'm recording. So first of all, let's look at one that is not a correlated subquery. Let's see, what am I? Find all invoice IDs, all invoice ID where the invoice total is greater than or equal to the average invoice total. The reason I said greater than or equal, I want to get every one of them. I want to get a line, at least one line for each vendor ID who has an invoice. Not all vendor IDs have invoices. So I'm going to select vendor name, invoice ID, invoice total from vendors, inner join invoices. Since I'm taking something from vendors and something from invoices, I'm going to have to inner join vendors and invoices. If that isn't obvious, then I haven't done my job here in chapter 5. I think that was chapter 5. On the V vendor ID equals the foreign key. Almost all, not almost all, a great majority of your joins will be on primary key, foreign key, the vast majority. Where invoice total is greater than or equal to, and I fussy about that word all. I don't want you to just say greater than or equal to. If you said greater than or equal to, it would work, but your teacher would not be happy. Because invoice total is money, and the thing on the other side of the relational operator, the greater than or equal to, is a table. It's not equal. It's not greater than. It's like saying, is my cup of coffee greater than Tuesday? It makes no sense. Okay, but greater than all, everything in this, select average invoice total from invoices. Now, this is not a correlated subquery. If I run this, I'm going to get the ones. I'm going to get, what did I get? 16 16 rows. So I have 16, and some of them I have 16 invoice totals that are greater than average. And I think we decided that we were skewed to the high side, meaning we've got a lot of big numbers in there, which pushes that average higher. So I don't get as many as I would get if I said less than or equal to average. I'm going to get a lot more invoices returned because I got a lot more of them for $2 and $3. Okay, now we'll change it slightly. We want the same data. But look at this. This piece of it. We want the same data. However, we now only want invoice totals that are greater than or equal to the average for that vendor. Somebody keeps texting me. No. Quit texting me. Okay. Here's the deal. We now want the same. However, we only want, here's the deal, invoice totals that are greater than or equal to the average total. You see this for that vendor. So basically, I can now have multiple invoices for that vendor. So I'm going to be comparing each vendor's average to every other invoice for that vendor. Okay. So it's not just comparing it. The one above that, I was comparing it against the global average. In other words, the average of all invoices. But now I want to split it up, and I want to compare every invoice to the average for that vendor. So it's kind of like a group by going on here, right? When you're in this situation, and you're not really often, are you? You need what's called a correlated subquery. Let's look at one. Here's a correlated subquery. Now, as the vendor ID, invoice total. Notice that I've made this one a little bit easier because I've taken the vendor ID instead of the vendor name. I think up here I had vendor name. Down here, I'm going to stick with vendor ID, so I'll use vendor ID because that keeps one table. I don't have to do a join in that outside query. I don't want to clutter this up with a join. There's nothing new about the logic, but basically, everything there I can get from the invoices. Are you okay with that? So I only need one query in this total from invoices as I1. I have to rename it. Where invoice total is greater than or equal to all. Now, select the average invoice total from invoices as I2. So I have invoices in that query twice known by two different names. In theory, you don't have to rename the outside table, but it is a good idea to just name them both so you can tell one from the other by just looking at the name. If I'd left it named invoices, it would have been okay as long as I renamed the inside table to something besides invoices. I just always name them both. Sometimes I name the first one outside and the other one inside. One of them is an outside query, one of them is the inside query. So I1 is invoices outside, I2 is invoices inside. Now, when I'm in the inner query, from this place right here, from here, I can look outside and I can see I1 okay. From the outside, I cannot look inside of the other one. This is how programming languages and variables typically behave. I can always look outside of a block of scope, but I can't look into another one because that's closed. It's like a one-way glass. I can see out, but I can't see in. That's not really a problem because here's where the rubber meets the road. Okay, where I1.vendor_ID is equal to I2.vendor_ID. So when as this one goes through, as the outside query goes through, the outside query says from invoices, select something from invoices, so it figures out what it needs from there, but it names that guy I1. Actually, it's just going to select all the invoices. And then the inner query is going to run, and it's going to select the average from invoices, but this one's named I2. And here, right here, is where we reference the outer table is equal to the primary key of the inner table. This makes it a correlated subquery. That is what makes a correlated subquery. Don't write a correlated subquery unless you have to, and you'll know you have to when you see something like this language or something that amounts to that. So I want invoice totals that are greater than or equal to the average for that particular vendor. And I want to know about all the vendors. When I see that kind of a statement, then I know I have a correlated subquery. They're fairly rare, not rare, but they're less than usual programming task. I would refer you to Dr. King's, you're shaking your head. Okay. Okay. Well, Dr. King is accurate. That's the video we have. He is accurate. I know him well. He uses a shortened syntax, and so he'll say, you know, table 1 join table 2, and I argue against that. There's nothing wrong with doing that, by the way, except in here. Later, if you want to write table 1 join table 2, you go right ahead. I tend to use the full syntax because I'm a teacher. Well, if it makes sense to you, then it makes sense, right? You do what works for you. And here you have to humor me. But is there anything wrong with saying table 1 join table 2 as opposed to inner join? No, not really. Okay. A minute ago, I said I'm going to use the vendor ID just because I like keeping this outer query simple. Now let's go ahead and let it be not so simple. Change vendor ID to vendor name. Well, life is still pretty, you know, if we just get over the fact that we're going to need vendors in the mix. Okay, so I just have to join vendors and invoices. Nothing special about that. Notice I gave invoice its alias. Its invoice is going to keep that alias. I aliased vendors, but I didn't have to. I don't, if you don't do it, if you want to say vendors.vendor_ID, that's fine. I don't like typing a whole lot. Okay, there's the inner join, and then the where. Down here we have the reference to the outer table named I1 and the inner table named I2, and that it makes it a correlated subquery. You get the correlated subquery when you see that language is what you're looking for that vendor. Hint, hint. Correlated subquery. Okay, that means you have to name a table outside, a table inside, and then the reference. If you tried to say outside, if you tried to talk about table I2 out here, you wouldn't get it. You wouldn't be able to see it. But you can see I1 from the inside. Let's run this. Notice, let's see, I got 56 rows. There. I think I'll get 56 here. They should be the same. There, I got 57 rows. Okay, that's what I wanted to see. Gee, why did I get a different number of rows returned? Okay. Notice that this one up here, this one that begins on line, this one that uses the vendor ID instead of talking about line numbers, that might change if I change something above, uses the vendor ID. So everything is coming from the invoices, just invoices. As soon as I throw in vendor name, I get a different number. Now I only get 56 rows. Something is dreadfully wrong, for I feel. What's the matter here? They're supposed to be the same thing. All right. Now, what did I get up here? And I'm going to pay particular attention right here to lines 2 and 3. Blue Cross invoice ID 46 and invoice ID 113, I think.
So because we are saying vendor name, it does not participate in that relationship. That's why it's
No, I'm still getting them. I think the deal is that I have an invalid invoice ID. That's my problem. So if I stay always in the invoice ID, and this, when you start seeing things like this happen, if I write the query one way, and all I do is add something that should be one-to-one, the vendor name should be, for each vendor ID, I should have exactly one vendor name. Excuse me, for each invoice ID should map to exactly one vendor ID, the parent key, parent table. Now, one vendor might have 0 or more invoices, but each invoice has to have one vendor assigned to it. Otherwise, what do I have? Not childless. There are lots of childless parents. Yeah, I have an invalid child. And so this is when you start seeing this behavior in invoices and stuff like invoice, and particularly invoice line items, I have introduced a few errors. So you'd see them. So if I ask you, why do you get 56 rows one way? So one way you get 57 rows if you use the vendor ID, but if you use the vendor name, which is also unique, it doesn't have to be, but one of the questions, how do we know it's unique? We don't. I just know it's unique. I'm expecting to see the same number of rows returned, yet we get one fewer. And that is a clue to the database person that something is wrong in my table. Okay. Now, what I could do is I could go through here and look for the invoice ID, Here's 57 rows. I think I don't remember which one it is. Yes, I do. I don't remember which one it is. I'll find it in a minute. And then I could look at this one and compare them to it. I could do, you know, a difference. I could take a set difference. That's a pain. Let's just do this. What do you think I should do? What would you try first? I'm going to unmute. Okay. If you guys out there in internet land want to talk, one at a time, please, you may. What would I do first? I think I've got an invalid invoice ID. Thoughts? How do I find an invalid child?
Would you do an outer join to
Indeed,
get all the values?
Indeed, I would do an outer join. The outer join will point at the child table where I didn't notice I didn't say left or right. For me, that'll usually be right, but not always. So I'm doing a right outer join. Okay. So I'm looking for an invalid ID there. Do a right outer join pointing at the child. Invoice ID 446. Well, that's not, okay. I guess I don't have the one written out here that I want. I want to select I can just select invoice ID from vendors as V. I on let's see, V dot vendor ID, the parent key equal to I dot. Okay, so I usually put the parent on the left and the child on the right, but you don't always have to do that. And I'm interested in where V dot I believe I have one. Now, this is the way I set it up. I always put the parent here and the child here. And they don't have to be that way, but it would change the right outer join to a left outer join. The outer join, when I say it points to, that means if it's a, excuse me, if it's a right outer join, it points to the right. If it's a left outer join, it points to the left. It points to the child table, where the parent table, parent key is null. And this will show me invalid children. If I change it and point it at the parent where the child key was null, I would find childless parents. Let's see what we get. There it is. My culprit. There is no vendor ID 68. Therefore, when I do the join up here, when I join invoices and vendors, this vendor ID of 68 does not come into play. So when you see a discrepancy like that, it's telling you that there's a problem in your table. This is a problem because having a childless parent, having a vendor with no invoices doesn't hurt me any. I can have a vendor with no invoices. I cannot have an invoice that is associated with an invalid vendor. That's bad. That's cheap menudo. You know what menudo is, don't you? Tripe. No. The cheapest cut of possible piece of a cow. I guess it's a cow. Okay. Do I have any invalid children in the invoice line items table? And in fact, I think I do, number 446. What about an invoice with no line items? Can I have an invoice with no line item? Yes, I think it would be. I think it would be okay as long as the invoice total was 0. But invoice 46 has an invoice total of $224, but it doesn't have anything on the invoice. Where does the $224 come from? Okay, more about that later. We're going to talk about that one. Okay, right now I'm done. Okay, are there any questions on, we're going to take a short break. Do you have any questions on the correlated subquery? Okay, I have gotten the recording on, so at least I've gotten it recorded. Okay, reviewing the correlated subquery. What is it? Invoice something. Not always invoice totals, but whatever, some value that is greater than, less than, equal to, or some combination, not equal to, whatever, of some aggregate function for that particular, for each vendor. So it's that I want something for each on a grouping by a vendor, and I want an average. You cannot have an average in the having clause. So I can't say having invoice total greater than or equal to average. That won't work. So I have to have the correlated subquery. The correlated subquery amounts to a nested loop, if you like. We don't talk much about a loop in SQL, but if you know anything about programming, you know there has to be a loop in there someplace. It's just hidden from you, is all there is. If you have an automatic transmission, it has to be shifting its gears some way. So it has to happen, whether I have control over it or not. Okay, I'm going to pause here, and we're going to, this is a good place to take a short break, and we will come back. When we come back, I will begin, what will I begin? I will begin data types, I believe, wasn't what I meant to do. And I will make the assignment. Somebody remind me to put a due date on the assignment for chapter 8. The subqueries. Subqueries tend to be the part that gives the student the most problem. However, subqueries are very, very powerful. For the most part, a subquery can be written in place of can be replaced by an inner join, outer join. My own personal preference is to write a subquery over a join. I'm not going to tell you one's better than the other. Subquery. We're going to skip module 9, data manipulation. I might come back to it. So we're going to skip chapter 7. We've already done something that's insert, delete, and update. I always feel like we need to do that before we start going into joining. We need to create tables first. So this would be create table. stuff like that. We need to do that before we start anything. Okay, so I'm going to begin in 10 minutes with chapter 10. It is now 10:54 according to my clock, and I'm going to pause the recording. Okay, we are back from break. I would like to talk about one little thing before I begin chapter 10. I'd like to go a little further into our AP database just for a quick second. Someone have a question? Okay, I'm gonna mute the people. Stops us from getting microphone noise. Let's see, I want to go to my Object Explorer. And I wanted to call your attention to the invoice line items table and the invoices table. There's something here that is a few things about them that are really bad. Let's look at the columns. Notice that in this one, I have a two-table primary key, or excuse me, a two-column primary key. I would prefer not to have this, and I don't really have to have it. There's a way I can get around it pretty easily. We're going to talk more about that. But let's look at this one right here. Let's look at the invoice line item amount, money, okay? Now, what is that? Well, that's the invoice line item amount, and then, obviously, that's what it says it is. Then let's also go over here to invoices. And I'll put him near the top. The columns of invoices. Notice that I have a column in here called invoice total. Where do I get the invoice total? Well, the invoice total is the sum of the invoice line item amount. Now, this has some bad implications. First of all, I never store anything that I can derive from the data. So given the data in these two tables, the invoice line item, the invoice total is always, or had better always be, the sum of the invoice line item amounts. I think if you check that, you'll find it isn't necessarily so. And this, because this possibility exists that they could be different. I don't know whether they are in yours or not, but they could easily be different. Let's see. So an invoice does not have to have any invoice line items. In that case, the invoice total should be 0. I think you'll find that invoice number, one of them in there, if you check invoices for childless parents, invoices and invoice line items, and you do a right outer join, or pointing to the child, you'll find that there is an invoice number in there that has no children, and it has an amount, invoice amount, but it has no associated invoice line items. Now, if I am in a situation like that where I'm trying to manage them all, now I'm in the position of which do I update first? Do I update the invoice total? In that case, it doesn't match the invoice line items. Or do I insert an invoice line item and have an invalid invoice total? Either way, it's going to be invalid for that fraction of a second that it takes me to get it updated. And there's always the possibility that someone will read an invalid value. Okay. as we get a little further along, we're going to talk about that. But you'll see if you are summing up the invoice line items, you're going to see that you are off by one in there, and it's those pesky little off by one errors that point you to something that's invalid. So you start looking at it. The first thing I would do is go through my tables and make sure I didn't have any invalid children. Okay. The foreign key is supposed to stop me from putting them in, but somebody can disable that foreign key, put some bad data in there, and then re-enable the foreign key constraint. And in that case, I have bad data in there. I got to go find it. Okay. I promised you chapter 10. Well, let's see, what are the student resources here? Come on. Give you the slides and I don't use slides a whole lot. I'm not a PowerPoint fan, but I give them to you in case you want to look at them. This is the Microsoft site. A general discussion of types. This one's pretty good. And then I say tutorial that's pretty good in spite of the ads. Okay, basically I'm just giving you some. Okay. We're on pages 240, 260. We're going to talk about the 4 fundamental data types used in SQL. We're going to talk about cast and convert. And we're going to calculate disk space requirements. How much disk do I have to have if I'm going to build my tables? I don't remember what this, there's a video there. Okay. Data SQL. In SQL, our data types fall into 4 big fundamental categories. And I'm going to say really 3 that I'm interested in. We have data types that is string or character data. Okay. That would be varchar or char. Talk a little bit more about that in a minute. Numeric, which include integers, floating point, currency, and other numbers. Anything that's a number. If it's a number, it's numeric. And temporal is dates, times. Most of the time when you say it's date, time, it's both. And I wish somebody would stop texting me. I'm going to turn this. I hate to turn this off because my wife has to be able to get in touch with me. She's having some, preparing for some surgery. She's got some foot surgery. It's not life-threatening. Okay, so dates, times, anytime that you talk about a date and a time, basically it turns into an integer, and it's the number of time units that have elapsed since a fixed time in the past. And then finally, what we call blobs and other things, binary large objects. There's several variations on a blob. There's blob and clob and inclob and all kinds of stuff like that. Basically, I lump them all together and call them blobs, binary large objects. And I am not particularly interested in these in terms of as a database person. I mean, they're important in that I can put them into my database. So, for example, I had a student once back at my last institution that he did a project for the database class wherein he put his whole movie library into a database, into a SQL server. And so he put them in there as blobs, and now he can watch a movie from his database. Now, the only thing, a blob isn't particularly interesting to me, unless the movie's interesting, because I cannot search on it. I can't say go look at the movies, the digital image of the movie, and find me a movie about cats. Unless that information is in a field, I can't do it. It's no help at all. So to me, I don't care. I can't sort on it. I can't say is one greater than, equal to, less than the other. I have no way of doing much with them. They just kind of are tacked in there and they go along for the ride with the rest of the data. So I'm not going to worry much about that. So I'm going to worry only about string, numeric, and dates next. Okay. No, I'm going to worry about integers first. Computer programming almost always treats integers the same way. Does the integer have to represent both positive and negative numbers, or is it an absolute value, unsigned? How much storage do we allocate for each integer, where 4 bytes is very, very, almost universally common? Okay. Unsigned is the simplest one. The integer is stored in base 2, just a base 2 number. That's pretty much it. The maximum value that can be represented is 2 to the number of bits. So if I've got 4 bytes, right, that's 32 bits. I'm 2 to the 32nd power. If you calculate that out, I use about 4 billion as my rule of thumb, where 2 to the 30th power is, something like a billion. It's not a billion, but it's close. 2 to the number of bits, so it'd be 2 to the 32nd power minus 1. If we used a 1 byte unsigned integer, which is a tiny int, the largest value we could represent would be 2 to the 8th minus 1, or 255. Once I go to roll over to hit that 2 to the 8th power and actually get there, now I need 9 bits to represent it. Okay. If we had a 4 byte unsigned integer, which we don't, but if we did, the largest I could go would be 2 to the 32nd minus 1. There's always one more than the number because we have to account for 0. Signed integers. Okay. Now, when we have a signed integer, our life gets a little bit stranger, because now I have to represent that positive or negative. One way I could do it, and the way they have done it in the past, is just to take off 1 bit and use the high bit, the farthest bit to the left. And if that is a 0, it is positive. If it is a 1, it is a negative. So you just strip off that high bit, look at it. That gives you positive or negative, and then you look at the rest of it to get the magnitude. That's the way we think about it in our arithmetic classes. So we talk about a number like negative 45 or positive 45. We don't write anything, it's positive, but let's just say we're going to write positive. So I have one character that tells me it's 0 for positive and 1 for negative. And then the other remaining, let's say 7 bits, give me the magnitude. Well, the problem with that is I now have 2 ways to write 0. I have to write positive 0 or negative 0, and they are both 0. That really throws a hitch into our get along. I do not want 2 ways to write the same number. So what we do is we use, let's see, do I talk about 2's complement? I don't think I do. Back to the 8-bit integer, we have 256 values. Half of them are negative. You might watch this YouTube video. Think of it as, the way I'm going to do it, I'm going to kind of, if I had a mechanical odometer, a device that records how far I've gone, and it's mechanical. In other words, if I go backwards, it runs backwards. So I start at 0, and let's say I have 3 digits. So it's like a bicycle odometer. When you get to 999, it rolls over to 0. And I start writing, and I have first one's 1, and then 2, and then 3, and then 4. If I start writing backwards, what will the first value I see be? Well, it'll be 999, 998. So the way I'm going to do that is I have to have some way of telling a positive from a negative. And I'm going to use this. If the first digit is 0 through 4, 0, 1, 2, 3, 4, then it is a positive number. If the first digit is 5, 6, 7, 8, 9, it is a negative number. Now, the way you will tell a positive number is just the number. If the first one's 0, if the first one is 5, 6, 7, 8, 9, you take the value and subtract from 1,000. Now this works out very nicely in base 2. The thing of it is, you will always have one more negative number than non-negative numbers, because by our scheme of things, by our definition of what positive numbers mean, 0 has now become one of our positive numbers. So my positive numbers are 0 through, and my negative numbers start with 1 and go through the largest number. This leads us into kind of a strange situation, and the way I talk about this, and I'm going to turn your microphones on if you want to, let me unmute. Okay. What state in the United States is farthest east? And you say? Maine. That's a good choice. And so if you drew a line down, I think you would find Maine possibly. I'm not sure how it wraps around. But it's a trick question, right? The state that is farthest east is Alaska. And this is true because if you look at the Aleutian Island Peninsula, jetting far, far to the west, it actually goes into the eastern hemisphere. So it's a piece of land there that has east longitude. Okay, that's a trick question. But if you go far enough west, you end up east. Well, what does that have to do with integers? Excuse me. Well, I'll use the idea of positive and negative. If I keep riding my bicycle and I ride my bicycle for 498 miles and I ride one more mile, and I'm 499. When I ride one more mile, I'm at 500. That begins with a 5. Now the value is negative. Right, so that would translate now to -1. So the largest, it would translate to the largest negative integer. So if it's 500, I would take 500, subtract it from 1,000 and call it negative. So 499, my next number would be -500. Then -499, 498, 497, as I'm riding in the same direction. So it's a little bit like I've crossed that 0 meridian, okay? All integers will behave thus. All integers, you heard it here, take it to the bank. All integers, there is no integer that can be represented either in a mechanical or a digital. The only integer that has no upper bound are the ones you find over in your math class, those theoretical integers that have no upper bound. Everything in computer science has an upper bound. It has a finite number of bits assigned to it. When you run out of those bits, you will do what we call overflow. If it is unsigned, when you hit the biggest value you can hit, it goes back to 0. If it is signed, when you hit your biggest positive value, you go to the largest negative value. All integers will overflow. integer overflow is fairly easy to detect. I add two positive integers and I come up with a negative integer. Or I add one to a number that's big and all of a sudden it's 0. You can detect it fairly easily. It is called overflow. What happens is the number carries out of the range. Think of some of you are old enough to remember when car speedometers did that. And when you hit 99,999, it would roll over to 0. Didn't mean it's 0, it means it carried out of its range. And it's my experience that a lot of students today don't remember cars that did that. Do you remember cars that did that? Okay. You know you're getting old when nobody remembers your examples. Do what now? Right. Well, it will overflow sooner or later. It's just that it's a whole lot cheaper to build an odometer, we call those things that record the distance. In a chip, it can have 32 bits or something like that. That means I can go up to 2 billion miles before I overflow. Sooner or later, it will overflow. Now, you'll have to buy a new car before you ever get close to that. But my guess is that it would overflow about probably 16 bits, 1,000. I'm guessing it'd probably go up to about 2 billion or so, because that's the simplest one. It is simple to use 32 bits. So we've just thrown more width at it. Sooner or later, everything will overflow. Every integer will. The only thing you can do is go out and make more money. And let me shut this off. I didn't mean to do that. This is pretty good discussion of that. Okay. How much storage? Bigger is better and better costs. If you use a big int, it's an integer, your storage is 8 bytes. That means I can go to -2 to the 63rd power, 64 bytes, -2 to the 63rd power, -1, or it goes from -2 to the 63rd power to 2 to the 63rd power -1. I have one more positive number than I do negative number. But when we're talking about numbers that are this big, let's see, that's thousands, millions, billions, trillions, quadrillions, quintillions, sextillions, 9 sextillion, 9 followed by a whole string of zeros. So if I've got 8 bytes, I have 64 bits, that's 2 to the 63rd power numbers positive, and 2 to the 63rd power -1 positive, and 2 to the 63rd negative. When you're talking in the sextillions, you don't really care about the 1. More commonly is the integer. The integer has 4 bytes, and that is about 2 billion positive, 2 billion negative. Actually, it's 2,147,483,648. But if you just think 2 billion, that'll be pretty close. Notice that each one of them, as I go down, I'm dividing by 2. A small int is has 2 bytes, and that is 2 to the 16th power different numbers, or 2 to the 15th power negative numbers, 2 to the 15th power -1 positive numbers. 0 has no sign. And finally, a tiny int is 1 byte. We do not bother putting a positive or a negative on that. You have to do that yourself. So if you have a tiny int, it's just a value. Double, overflow, all integers will overflow. There, I say it again. And then I'm going to say another thing. Anything with a fixed decimal point is an integer. If I fix the decimal point, it is an integer. Money, I will never store something as 17 and 23/100ths dollars. I will never store that decimal point. I will always store it as 1,732 cents. I will roll that decimal point out. And then when I show it to you, I'll fool you and put the decimal point back. The way I'm going to store it is always in pennies. Now, actually, do I say it in here? Money is actually stored in 4 decimal places. We don't need to worry about that. It is a fixed decimal point. Fixed decimal point means it's an integer. And we like integers because, well, I'm going to talk a little bit more about that. Decimal and numeric. Okay, so I say a decimal number. In SQL Server, we do not use numeric, but we can. It's depreciated. It is preferred to use decimal. So if I want to create a number that has a decimal in it, I say create the data type is decimal, DECIMAL. Open parentheses, 8,3. This means give me at least enough storage to store 8 base 10 digits. You'll probably get significantly more than that, but at least enough for 8 decimal digits. And of those, 3 are to the right of the decimal place. So if you add up the digits to the left and to the right, they will total to 8. You have at least that much space and maybe more. It will have 3 digits to the right of the decimal place always. If you only have 2, it's going to give you 3 by appending a 0. Okay, that's a fixed decimal. Anytime we have a fixed decimal, what did I say we had? Anything with a fixed decimal is an integer. It's a fixed decimal. It's an integer. I'm just going to shift that decimal out, store it as an integer, and then remember to put the decimal back in whenever I use it. Thus, fee may contain 8 digits. It has to be able to contain that, 3 of which are always to the right of the decimal. We have a fixed decimal. How big is it? Well, if it has 8 digits, that means it will contain 100,000 different numbers. It will require, if we take a log 2 of that, I'm not trying to lose you in this math, but if we take a log 2, we see that it will require 27 bits. And 1 more because of the sign, so it requires 28 bits. I can't allocate 28 bits because I allocate on byte boundaries. Chances are I can't even allocate a byte. Probably going to allocate. So what I'm going to allocate is 32 bits, or 4 bytes for that. So we stay on those byte boundaries. I will almost never allocate 3 bytes. For any integer, figure you're probably going to, any decimal number is probably 4 bytes. Excuse me. Yeah, probably 4 bytes. And if it's big, it's probably 8 bytes. Money is always 8 bytes. Fixes the decimal place at 4 places. Yes, money is also an integer. The one thing about money in the world is that money is, we try to keep, the world tries to keep their monies more or less comparable. For example, in the United States, we have a dollar. This reasonably well corresponds to a franc. Not exactly, or the German mark, or the Russian ruble, the Japanese yen, Thai baht. That's a basic denomination of money. Some of them are worth more than others. They will change from time to time. But that is always they are always represented in a 4-digit decimal. There are always 4 digits to the right of the decimal place anytime you're talking about money, whether it shows them to you or not. therefore, it is possible to have $1.0653 would make sense. There's 4 decimal places. If 2 of them are 0, that's fine. Now you're to the even penny. But it always represents it internally as having 4 decimal places. That's why you will see money come back with 4 decimal places sometimes. Anytime it carries out of that, it'll show you the 4 decimal places. And gasoline, I don't know, why do we have gasoline and, $2.28.9? It doesn't make any sense. Have you ever seen it as 0.8? There's no reason we need to show that 0.9. It'd be easier if they just rounded on up and stay to the even penny. But that's the way it worked. I can remember when you used to see 0.6 pennies or some other than 9. It hadn't been something other than 9 for 50 or 60 years. Summary: integers are limited by the number of bits allocated, actually. Anytime we fix the decimal point, it is an integer. All integers will overflow. Important point here. Here is a final question. This one will be on the test. What is overflow? Overflow is a carry to the left out of range. Unmuted. Questions from anybody?
Hello?
Yes.
This is Doug.
This is who? Doug, got you. Go ahead.
I just wanted to make a comment, not really a question. The gas prices are stated in tenths because in the year 1933, the government imposed a 1.5 cent tax.
Okay.
That's what it goes back to. It's trivia.
Well, now I have seen it in something besides 9 in my
Yes, it was
memory.
Originally 1.5 cent tax.
Mm-hmm.
Yeah.
I remember seeing like gasoline was, 28.6 cents a gallon or something like that.
Yeah.
But anyway.
The government opened the door for all those different tenths.
Yeah. Today, there's no particular reason. A tenth of a penny has very little value.
Exactly.
But nonetheless, a penny is divided into 100 pieces. There is a coin that exists someplace. Maybe it's just theoretical now, but when I was a kid, it existed. That is 1/100th of a penny.
Oh, yeah.
Wouldn't be worth picking up.
Right.
Others? Okay, go ahead.
You said, like the overflow would be in a test, so there would be the theory questions too.
I'm sorry, Anita, I didn't quite get that.
You said that this is a test question.
Well, what is overflow?
So there would be the theory questions, like descriptive, or all the questions?
Yes, there might be something like this. What is overflow?
Okay.
Overflow is a carry to the left. So an overflow, when something overflows, it gets too big to fit. So it chops off the left digit. So it's like when your numbers grow to the left. So if you start writing on your right-hand margin, your numbers are growing to the left, knowing where each tens line up. So if you double each time, it's getting bigger to the left. When you run out of paper, you go off the paper and it looks like you've gotten smaller. That's overflow.
Thank you.
Okay. So it's a carry to the left. It's a carry on the high side. We're going to see one now that is something different. Okay. I'm going to mute. Okay, floating point. Consider some fractions and whether or not they terminate or repeat. 1/2 terminates, 1/3 repeats, 1/4 terminates, 1/5 terminates, 1/6 keeps repeating. In other words, I'm going to get if I try to divide it, if I try to say 1 divided by 6, It's not going to end. Neither will 1/7, but 1/8 will, 0.125. 1/9 won't. 1/10 will, 0.1. What is the rule? Well, if we're in base 10, 10 has two factors, 2 and 5. If the denominator has any prime factors other than 2 or 5, it will repeat. For example, here we have 3. 3 is a prime number. It will repeat. 4, 2 times 2. 5, 1/5. 5, that's a factor of 10. 1/6, that is 2 times 3, and 3 is not a factor of 10. 7 is a prime. 8 is 2 times 2 times 2. It's only got 2's. 9. For example, the next number that will terminate after 1/10 is going to be 1/16. A computer represents numbers in base 2. The floating point decimal, 0.2, will not terminate in binary. Why? Because it is 2/10. If I were to reduce that 2/10, I would get 1/5. 5 is not a factor. 5 is a prime number other than 2. It will not terminate. So if you talk about 0.2 or 0.01, 1 penny, if you try that, and once you shift over into base 2 and you're talking about pennies, that will not terminate. Now I have a problem, because if I have to represent this as a floating point decimal, I'm going to get something that just goes forever and ever and ever. It's like 1/3, for example. Let's talk about 1/3 in base 10. What do I get? 0.33333333333, and you finally gonna get tired of sitting here saying threes. You're probably tired of hearing it right now. So I just have to quit. When I quit, I've introduced an error, a very small error, but an error nonetheless. Okay. This is called underflow. Okay, a minute ago we had overflow. What is the difference between overflow and underflow? Well, overflow is an error on the left-hand side. It is a carry out of range. Underflow is that little insidious error on the right-hand side. Underflow happens because we cannot represent an infinite binary point or decimal point or whatever. Therefore, I have to end it someplace. And when I end it someplace, besides carrying it all the way out to infinity, underflow has occurred. Underflow will occur. In general, overflow is a drastic error on the high side, but is easily detected. Do something about it. Underflow is an insidious error that is so tiny that it's not considered important. But anybody seen, I'll open this, let me turn you on. Okay, your microphones are turned on if you want to talk. Has anybody ever seen the movie Office Space?
Yes.
Yeah. What was their scam in Office Space? Well, they skimmed off a few pennies. They had an error of less than a penny in every check. Because if your check were 4/10 of a penny short, would you ever notice it? Do you pay that close of attention to your check? You'd never notice it. What would happen if they went ahead and charged your gasoline at, instead of charging you whatever it is now, $2.24.9, what if they charged you that extra 1/10 of a penny? Would you notice it? No, you wouldn't notice it. What if you had some way of collecting that 1/10 of a penny from everybody that bought gasoline for a year? How much money do you think you would have? I don't know. I don't have a clue. I guess we could probably get an estimate of how much gasoline we used and figure that out. But every time every gallon, we get 1/10 of a penny on it. And that adds up quickly. There's lots of stories you can tell about that. For example, one of the early, back in the early days of rocketry, this would have been in the 1950s, I believe. We were starting to shoot rockets and trying to get an orbit. Let's see, when did we get the first orbit? I want to say 1962 or something like that. And the computers were rudimentary. And note, anytime you're going in a circle, you have a factor of pi in there. Well, pi is an irrational number. It never terminates. So as the first space shot they shot up was a partial orbit with a person in it. And it landed and everything's fine. Then they went a little farther, and then they did one full revolution, one full orbit, John Glenn's famous orbital flight. And there was a little bit of an error in that, but not really enough. They probably figured it was due to the wind or something. And then they had some, I forget the astronaut's name, who did he stayed up for a better part of a day in orbit, and he did multiple orbits. And when he landed, he didn't even come down in the right ocean. And this was because he had this cumulative error, little bitty error that you didn't notice in a short flight, but as it went longer and longer and longer, it started adding up, and it totaled up to a significant amount, right? That is called underflow. Poor guy sitting out there floating in the wrong ocean. Wonder how long he had to stay out there. I don't know. I'll have to read that book. I think it's documented in Thomas Wolfe's book, The Right Stuff. Okay. Now, floating point. Never use a float unless there is no way around it. When you use a float, you store the number as a number with a, well, it's not a decimal point, but I sometimes say decimal point, even though it's a binary point, times some power of 2. So it's stored in scientific notation. You only have 8 bytes. So at some point, you're just going to run out. And if you start adding up a penny as if your penny is 0.01 floating point, and you add them up enough, I have a demonstration I do with that where I start adding pennies as 0.01. And I add them up, I just add pennies in a loop until I get, I don't know, $1,000. When I get $1,000, you're starting to see an error in there. When I get to $1 million, you have a fairly large error in it. So the bottom line is float. Float is a 4-letter word, but sometimes you don't have any choice. Sometimes you're stuck. If you're doing calculations that involve physics or a circle, going around and around in a circle, how far did you go? You know, the circumference of a circle is pi times the diameter. Oh, well, there's no way around it. So if I know the diameter, then my circumference has a factor of pi. And if I know the circumference, my diameter has a factor of pi or 1 over pi, whatever. And I'll always have a underflow error. Other financial calculations, many of them have underflow errors. I do not like float, but sometimes I have to. This is why money, if I use money, money is always an integer. Integers do not underflow. It's a nice thing. An integer never underflows unless you're doing division. We used to use the data type real instead of float. Real is depreciated, don't use it. So floating point or float. So integers, if it's a fixed decimal, what is it? It's an integer. What is the error that integers suffer from? I'm not going to unmute right now. And the error is overflow. Integers overflow. With respect to a floating point number, that's a number with a decimal point in it. What kind of an error does it suffer from? Opposite of overflow. Underflow. What is underflow? Underflow is chopping off a decimal that either doesn't terminate or doesn't terminate in time for us, or we have to chop it off. We have a finite amount of storage. If I get too big in an integer, I chop it off on the left. It's obvious. If I get too many digits in a decimal number, I chop it off on the right, and it is much more difficult to detect. Overflow is drastic. Underflow is insidious. Overflow doesn't happen very often. When it does, it's obvious. Underflow happens on almost every floating point calculation and eventually adds up. The bottom line of this is we do not use float unless there's no way around it. We try to stay in integers, and if I have a fixed decimal point, that's an integer. Questions? Next. Almost out of time, but we'll continue now. Character data. Again, we're faced with we got 4 questions actually. Let's start with the first 2. Will we use only Western European characters? Now, think carefully. Once that decision to limit the character set to only Western European characters, meaning the ones we use in the United States, came as a shock to us that there were other people who used other character sets in the world. You know, oh well. But we got over it. And if I go to allow other character sets, because if I'm going to allow you to store stuff in the database, in the Korean language, in the Japanese language, in the Chinese language, in the Cyrillic alphabet, I'm going to have to go to a larger character. So if I'm only going to store ASCII code text, then I can get away with a 1-byte character. So just a char is 1 byte. Or will we use extended character sets? This is important because if you limit it to ASCII, it's difficult to change later. Difficult means it is a great deal of work for your database. Now, I got a pretty lazy database, but my database only has 300 or 400 rows in it. So that's nothing. You know, if you're talking about a database that has millions and millions of rows, now you're going to shut that database down a while trying to change it. Okay, I'm coming back to this one in just a minute, and here's the other question. Will our data have a fixed length or be of varying length? So this is char versus varchar. Okay. Char is a fixed length. Char is where I will always use 8 characters. Always allocates 8 characters. This makes it easy on the computer to allocate 8 characters. If you go over 8 characters, I think you get an error, and varchar, it allocates as much up to that number. So if you say varchar 16, it will, and you only use 8 characters, it will only allocate 8 characters. I think if you go over on a varchar, on most platforms anyway, if you go over on a varchar, it just chops you off. If you go over on a char, it throws an error. I'm not sure that SQL Server behaves that way, but bottom line is you have an upper bound on both of them. The upper bound is, in this case, S. That's this number right here. So that could be 16. 16 characters up to 16 characters. Which one is better? My rule of thumb, if it is short, what do I mean by short? Oh, I don't know. I'm just going to pick a number and I'm going to say 32 characters is pretty short. 500 characters isn't. Okay, so somewhere in between there is the definition. I don't know what you call short, but if it's a short, so if it is a social security number, for example, that's going to be characters. That's not a number. Those are characters, because it makes no sense to add, subtract, multiply, and divide. And how many are in a social security number? Well, there's 9 right now. If I were setting up social security numbers, I would start adding some to it. And there's 9. I would go up to the next power of 2, and I would allocate 16 characters just to be sure I always had enough. And I would allocate it as type char. In other words, every one of them would contain 16 characters. Why would I use the char instead of the varchar? Because there is work that the computer has to do to make that grow and shrink. And since they're always going to have about that number in there, I'm just going to allocate that number. That's short. 16 characters is short. I will allocate it as char, a person's first name. I'm probably going to allocate that as char instead of varchar, even though I have been demonstrating using varchar. Variable length characters is varchar. That grows and shrinks. There is overhead that the database has to do to grow and shrink. That has a cost. Nothing is free. So do I pay the cost of having more space than I'm really using here, or do I pay the cost of having it grow and shrink in varchar? Which one's better? My rule of thumb is if I get over, I usually think about 64 is where I'm going to go to a varchar. Again, it depends on how much variation I expect in there. If they're all going to be the same to within 3 or 4 characters, I'm going to stick with char. Now, if I go to the extended character set, it is the nchar and the nvarchar, or the types that you use. And this allocates 2 bytes per character instead of 1. We see varchar 8 or some similar size in practice. Okay, here's where I say anything under 64 is small. That's just my arbitrary definition. You might have a different one. Then use char. Varchar can save space. It comes with a cost. If I'm only going to save a couple of bytes, it's not worth incurring the cost. Here I talk about null. One more little issue. It is quite possible to have a name that has no characters in it, right? A null field has nothing in it. If the field is char or varchar and it contains the string quote, single quote, single quote, single quote, that is a value. It is the string that contains 0 characters. The string that contains 0 characters is not a null field. Ouch! Anybody have any comments on that? Unmuted. Anybody?
How is that possible?
How is that possible? It is possible to have a name that has 0 characters in it, but that field is not null because that field contains the 0 length string. If a string has 0 or more characters, it can have 0 characters and the length is 0, but a string exists, versus a field that is null that actually is nothing. And that will be the bane of your existence in database. Because I'm not going to let someone in my database that doesn't have a name. Okay, I've got a name. What's your name? My name doesn't have any characters in it. My name is some weird, idea. My name is next Thursday. It is a strange thing, but if you look at Access, some of you have taken the Access class. When you create a table and a field in Access, one of your options is allow null, or required. Access says you have to check required, yes or no. The next option is allow 0 length, meaning those are 2 different requirements. And I hate it in Access because Access defaults to yes, allow 0 length. That should be no, because if you're going to say it's required, then you probably don't want it to allow 0 length. Maybe you do, but you should have to check it. You should have to select, yes, allow zero length. So you can have a field that is not null, a char field, char varchar, that is not null because it contains the value single quote with nothing in it. And that is not null. That is a valid string. Ouch. Other comments? Yes, I know, it's weird. There's really no way around it logically in database. Okay. I have it, here I'm showing a constraint, check that it is not null, that's fine. Next line, check that the length, LEN, last name, we're going to see that in the next, we're going to see a lot more of this one in the next module, is greater than 0. In other words, check that it has at least one character in it. And when I talk about LEN, that's going to check that it has at least one non-space character in it. So that won't let me get by with, what's your name? Well, my name is space. They call me Spacey. This matter causes us a great deal of trouble. So those of you who think that's weird are correct. It is, and we think it is too, but you're going to have to deal with it, so get over it. Well, we're at 12 noon. I'm going to cap it off here for today. I'm going to go ahead and make the assignment. This is dates and times. Basically a date, we can have a date, a time, let's see, date time 2. Most database products use date time. I think this date time 2 has depreciated, and I think now it's just date time. There's reasons why this happens, and they get called something weird like date time 2 or varchar 2. And I have a whole lecture on that. Basically, a date, if you just say date, it has no time value. And if you say time, it's the time of day only. And I'm going to say, I think it is date time. Now, I think we've dropped that too, and it's a date and a time. You can store a date only in a date time. In that case, the time defaults to 0 o'clock, or which is midnight on the day before. And let's see, at midnight tonight, at the stroke of midnight tonight, today is November 2nd. Let me unmute for some discussion here. Today is November the 2nd. When it hits the stroke of midnight tonight, what will the date be? Right at that instant, midnight, bam. What's the date?
It's neither, it's in between.
It has to be one. It cannot be both.
Well, then it would be the old date until it's changed to the new date.
Okay. I believe that the stroke of midnight is in the next day.
Oh, cool.
I think that's the way it is. I'd have to research that because time doesn't have a instantaneous value, because the idea, even looking at it, takes you some time. But I think that if you're dealing in seconds, that second, I think, is in the following day, and midnight last night is in today, I think. Then you get into the problem of, is it AM or PM? Well, AM means before meridian and PM means post meridian. So in theory, midnight would be both. But we have an arbitrary way of handling all that stuff. Anyway, date and time. Dates and times are stored as integers. I'm going to talk a little bit more about that. And I'm going to talk about its default format and all that good stuff. So we still have a little bit to do here on dates and times. And we will continue that on Friday, next Friday. I'm going to, let's see, I need to make the assignment. I'm going to stop the recording now.